Now that we've discussed the theory for the network protocols, encapsulation, and the headers, we'll now apply our knowledge and skill to the static capture file, file2.pcap.ng. You can open the file to follow along and complete the steps as I do if you would like. Once the file opens, as you see here, we have it open. We first want to look at our IP header. We want to select this packet number 3. Once we've selected that packet, we notice that it is an ICMP packet. And look at the middle window. We see here we have a frame, followed by Ethernet, followed by IP, followed by ICMP. So again, that shows our encapsulation. All of this is encapsulated within IP. This is what we mean when we say all protocols are encapsulated or contained within each other. In the middle window here, if we expand this section of the IP, the Internet Protocol, we can see more information. So if we highlight here IP, we see down here in the bottom window, all highlighted in blue, that's the entire IP header. It's represented in hexadecimal, as we said. It's noted here with the start, so if we click on the version 4, that 4.5 signifies the start of the IP header. So remember, it's easier to read this in hex than in binary. So now if we go down here and we click on this protocol type, we see that the protocol type ICMP is represented with a decimal 1. That's what we're showing here. So that decimal 1 highlighted in blue in the bottom window tells us that the IP has the encapsulated protocol of ICMP. Now if we go to packet number 5. Now in packet number 5, this is a UDP packet. It's encapsulated again with the IP header. And we see this right here because UDP is hexadecimal 17, or highlighted in blue. We don't have a 17 in hex, therefore it's represented by an 11. So if we look here and we collapse this again, you see IP has the encapsulated protocol UDP, and contained within that is data. So if we expand UDP again, we see it's a very simple header. Why is that? Because it's connectionless. And since it's connectionless, it's a more simple header than what we have when we look at TCP. So now let's take a look at TCP. Now if we go to packet number 17, so we come up here to our trace, and we start seeing some packet traffic here, packet 17, which is going to port 21, which is TCP. So now what we want to do is right here we see IP with the encapsulated protocol TCP. So if we click on the IP and we expand it, we see the protocol that's encapsulated right here represented is in the bottom window with a 6, which is representation for TCP. So this tells us TCP in fact is the encapsulated protocol. Now if we scroll down to where the protocol is located and we expand that and we scroll down, you see there's quite a bit of information contained within the TCP header. And that is so we can do our connection oriented. And mainly what we want to focus on is these flags. And we see here the send flag or synchronize, which basically says open a connection with me. And we'll discuss that as you get more skills, right? We can expand that. Remember from the slides, we showed you the control bits or the flags. As you see here, these are the main control bits or flags of TCP. Right here is the main ones we're going to focus on: urgent, acknowledgement, push, reset, send, and fin. Right now we have a send flag set. You'll understand what that means when we build your skills a little bit further. These flags help us determine normal and abnormal traffic, as well as a few other things as well. In this section, we reviewed the network protocols and we verified encapsulation. Next, we will review details of the connections that take place within a network and identify different characteristics of the network communications.